Good morning, afternoon, or evening, depending on where and when you're watching this digital presentation. Welcome to Oracle CloudWorld. I'm Jon Mittelhauser. Today I'm going to be talking about a project called Spectra, internal code name for a project which is all about supercharging Fusion applications by using OCI Cloud Native Services. First, let me tell you who I am and why I'm talking to you. Right now at Oracle, I'm running the technical architecture team for the applications org. Project Spectra is one of our major projects that we are in the process of working on. Before this at Oracle, I was the vice president of developer services within OCI. So I'm very familiar with OCI and the services that we're building on top of. My team there launched 6 global services. Those include our Oracle Kubernetes engine, OKE, functions, API gateway, Cloud Shell, etc. Back in the dark ages, previous life, I am somewhat infamous. I co-wrote one of the first widely used web browsers, NCSA Mosaic, and was a founding engineer at Netscape. Have been involved with software engineering for more years than I would like to count. I was also a CEO for a startup and various VP engineering roles. So I've dealt with some of the other end of applications like Fusion, dealing with capital management and finance and things like that. So I think I have a pretty good background to sort of experience both sides of it, and hopefully, as I'll talk about, rebuild Fusion apps, evolve Fusion apps into a cloud native service, which is basically the key here of my slide. What is Project Spectra? It's an internal code name for a project around a major initiative. We're looking to evolve Oracle Fusion applications to an OCI-based cloud native architecture. So if you've heard Larry's keynotes at various times, he talks about one of the main benefits at Oracle is we have technology up and down the stack. We obviously have the best database in the world. We have one of the best clouds in the world that is evolving, OCI. I'll talk about that. And obviously some of the best applications in the world. And we kind of have this unique advantage that we're able to tie all three of those layers together into a customer solution. So OCI obviously is a relatively new cloud, and this project is really around taking advantage of some of the capabilities that has been built on OCI to provide a better architecture going forward. If you're not familiar with what I mean, what other people mean in terms of cloud native, some of this is coming from the Cloud Native Computing Foundation. And I'll mention that Oracle is a platinum member of the Cloud Native Computing Foundation. I was actually the first representative for Oracle for the first couple of years. Cloud Native Computing Foundation is an open source foundation that kind of all the major players are part of to standardize around some of these services. Kubernetes may be the part of that you're most familiar with, but there's service mesh and other things. In general, and obviously all of these can be somewhat subjective, the difference between kind of cloud native apps and kind of classic, shrink wrapped, install in your own servers applications they're really designed to be built and exploit the scale, elasticity, resiliency, and the flexibility that clouds like OCI provide. That's done using technologies like Kubernetes, Docker, etc. And what you end up with is these loosely coupled systems that are resilient, manageable, and observable. So that's kind of the definition. If you look on Wikipedia and other places, I'll talk about what that means for Fusion applications as we go. Specifically, that is our goal, is to make Fusion applications, evolve them to leverage the power of OCI. There are sessions during CloudWorld talking about OCI, so I'm not going to get into a ton of detail here. But at the highest level, we're leveraging the fact that this is a next gen and it's enterprise grade cloud. So unlike something like AWS, it's really designed for anybody from a kid in a dorm room to maybe some crazy little startup trying to do things. OCI is all around kind of enterprise use. And so we'll talk about some of the capabilities there, but it is one of the fastest growing networks of data centers. We have 40 regions now, 4 more planned. a ton of services to build on top of. And I'll talk about the key ones when it comes to Project Spectra and evolving Fusion applications. The benefits of OCI really are that flexible infrastructure. Resources scale up, scale down, off-box virtualization, and we'll talk about security in particular, some of the things this provides, because obviously that's a key enterprise feature. But isolation between various customer VMs, et cetera, so there is no way to get between them. Similarly, kind of the performance around the non-blocking networks, the L2 network virtualization. There's a link here at the bottom, to oracle.com/cloud. That obviously has a lot of information, as well as the OCI specific sessions at CloudWorld. I would encourage you, if you're not familiar with OCI, to go explore those sessions as well. In terms of why it's important for Fusion applications, the enterprise security is really the key thing. So that zero trust approach that's built in from the scratch on OCI, all data is encrypted by default, rest and motion, automatic detection of and remediation, importantly, of things like misconfiguration and policy breaches. We leverage all of those when we're building Spectra services, when we're building next-gen Fusion application services on top of OCI. And then obviously at the core of everything within Oracle is around the database. And we are the experts at both improving the database and building the security and ensuring that we automatically supply patches, no downtime, et cetera. Obviously, again, there is a lot of resources, there's other sessions talking about those, so I won't try and, explain all of that, but that is key to why we believe what we're doing will lead to much improved, evolved. I'll talk about kind of the benefits of Project Spectra. Fundamentally, this is kind of the key in terms of understanding what we're talking about and why I say evolve. Fusion applications is an existing stack of software that is running that you may be a customer of, many aspects of that. What we're not looking to do is tear that whole thing out and replace it all at once. What we're looking to do is build complementary services around that. And specifically, what we're looking to do is do those in a way that is shared and maintains the security. And again, I'll talk about kind of the key aspects of that as we go. But what that means is you have a shared security layer like the application firewall, the web application firewall, the WAF at the outer edge where the customer is accessing this information. You have a shared identity across these new services we're building and the existing stack of Fusion applications. And at the bottom, you have that shared database instance. We're not separating out the data. So the Fusion apps then are built on top of OKE, running obviously VMs and the services, and I'll give a little more detail there as we go. But the key, and I've alluded to this a couple of times, and so you probably see what's happening here, is what we're looking to do is create new functionality and importantly move gradually over time some of the existing functionality of that existing stack of Fusion applications into independent cloud native services. So what you'll see is these new services being released, although actually I'll get to the fact that this is kind of under the cover, so you won't necessarily see it yourself. What you'll do is you'll get the benefits, and I'll talk about that. But these new services are being built as cloud native services on top of OCI and directly integrated, complementary, using the same database as the existing stack. So you're going to get new functionality built in the new way, and we're going to gradually move some of that existing functionality over time, as opposed to trying to do a complete, shut down, rewrite, relaunch the whole thing. This is meant to be something that, allows us to innovate, under the covers for you, our customers, without stopping the innovation of new features and other things for a long stretch of time. And specifically, I'm obviously running a technical architecture org. We're building these new cloud native services using kind of the modern development pipeline to get continuous integration, continuous development. We're building teams around independence service teams using DevSecOps principles. So you'll hear a lot about that, especially if you attend things like CNCF, Cloud Native Computing Foundation meetings, KubeCon, et cetera. That's kind of what I and others are bringing into how we're innovating around Fusion apps, and really leveraging a curated set of those CNCF Cloud Native services that we run on top of OCI. So, why do I say curated? Well, this is the CNCF Cloud Native landscape. It is a eye chart. As you can see, I don't intend that anybody can actually read that. That's kind of the point. These are all independent projects, services, commercial, open source, et cetera, grouped into different categories. This is something that on the CNCF site, they keep up to date. But the point is it's enough to drive you crazy. So if you recognize memes, this is something that I found amusing that kind of went around the CNCF Twitter, et cetera. It is not something that we want all of the Fusion app developers or customers, because you're going to be directly exposed to some of these, to have to figure out instead. So what Project Spectra is doing, what my team is doing, is curating and choosing the best of breed technologies to build these things on top of OCI. So specifically, probably a given if you're familiar with Kubernetes, I mentioned it before, OCI's Kubernetes engine, OKE is the name. That's kind of the base of what we're running Docker containers on. The part you may not be as familiar with, even if you're familiar with containers and Kubernetes, is Helidon. So if you have access to the Java the Java sessions within CloudWorld, Helidon is an Oracle open source Java microservice library. So for the services that are being built in Java, and those are most of our services, Helidon is a key part. And again, I would encourage you to visit those CloudWorld sessions, learn about Helidon. It's a quickly evolving and very powerful microservice framework, and we leverage it a lot. And then the other technology I haven't mentioned before is the streaming service on top of OCI, which is a Kafka compatible streaming service. And that's really, if you start getting into cloud native technologies, one of the things that these kind of independent services need, and we also use between kind of the existing stack and these services, is reliable ways to pass messaging around. And that is something that OCI streaming service provides for us. So these are the core things under the covers that we're building services on top of from a technical standpoint. And then we get to why did we call it Project Spectra? And, again, that's a code name. It reflects, we sat down at the beginning of this project and came up with kind of what some of the core principles we thought of this effort needed to be. And we made an acronym out of them. And I'll talk about each of these and kind of how it's reflected in terms of what we're building. But specifically, the principles that we thought were important to capture as part of Project Spectra were security, performance, elasticity, customizations, telemetry, resiliency, and agility. So I'll talk kind of each of these, what we're doing around those, why we think it's important. I think a lot of them are kind of self-explanatory and why they're important, but what it means when we're building new cloud native services. So we want to lead with security. For enterprise customers, that is incredibly important for obvious reasons. And one of the unique things in terms of how we're architecting Spectra, Project Spectra, the Spectra services, is this idea in a classic microservice architecture, each service has their own data. Data gets moved around. It lives in a bunch of different places. And they tend to be built such that customer data is all intermingled. And, for something like Netflix, a consumer application, that may make sense. It does make sense for them. They're kind of the canonical example of thousands of microservices. And to be specific, we're not looking to build thousands of microservices. We're looking to build tens of major services. And very specifically, one of our core principles under the security guise is that each customer has their own Oracle database instance. So this is true with Fusion, the existing stack, and this is true with Spectra Services. They use that same database. I alluded to that earlier. I talked about that earlier. But that means, from a security standpoint, that the data from different customers are never intermingled. And even data within a customer, if you have different pods, if you have stage pods and test pods and your production pods, that data is never intermingled. So one, your data is not mixed with other customers, and two, all of that customer data lives in that single database. So that allows us to secure that customer data at a single point, allows things like disaster recovery to be much simpler. If there is a natural disaster in a region, that data, if disaster recovery is set up with that service, with that Fusion applications, that can be kind of all restored in another region as a single unit without having to worry about service by service. And again, you have a shared identity system. So we're not looking at, this having to worry about the authorization, the authentication differently between the existing Fusion stack and these new services that are being built. Similarly, and I had this on that first slide, we're sharing a common kind of edge security layer, specifically using the OCI WAF, Web Application Firewall. What we're talking about here is user interfaces that tend to be web interfaces or REST APIs, but the WAF is a layer that provides, protection from internet threats like cross-site scripting, SQL injection, et cetera. So again, there's plenty of documentation on the benefits of WAFs in general, why OCI has a very powerful and good WAF. The key here is that we're sharing all that configuration. So anything you do is true across all of Fusion, whether it is the existing stack or these new Spectra services that are being built, these next gen Fusion services. And then we're taking advantage of kind of modern best practices around how we're building a cloud native app. So Kubernetes in general, we do things like automatic security patching of the worker nodes. We've built in capabilities to do zero downtime rotation to the latest Oracle Linux. That all happens automatically for these services. So, it's a DevSecOps model, but the system, the platform is handling rotation for those, ensuring obviously the latest security fix on those operating systems are automatically available. And then, if you're familiar with Kubernetes, you may know of something called Gatekeeper. This is a layer where we can put rules around security policies as well. And for example, in Spectra, we have rules to enforce things to ensure either nothing happens accidentally or, in case of any intrusion attempts or anything like that, we're protected. So things like not allowing those containers to run as root and not allowing read-write file systems on those containers. So, we ensure that the containers are idempotent, they can be killed, they can be restarted. That is sort of the core of a cloud native service. They can't store data. All of the data is stored in that common database for the existing Fusion apps. And obviously, in a modern world, everything is using MTLS-based encryption everywhere. So those are kind of core sub-principles in the security principle of Spectra that we're building these new services around. Similarly, after security, performance is one of our top, principles that we want to ensure from the start. We talked about how OCI provides kind of modern hardware networking. Many of you have experienced that as Fusion pods have moved from the original Oracle Cloud to OCI. Many customers have seen, large improvements even without changing the software, just because of the networking, because of the hardware it's running on. Obviously, we want to take advantage of that. But fundamentally, there are aspects of Fusion apps that have been written over, a long period of time. There are sessions during CloudWorld talking about Visual Builder, Redwood, et cetera. All of this is the kind of underpinnings of the modern UIs that are built on top of Spectra and built on top of the existing stack. But everything's using asynchronous APIs, for example. And then, we want to always be leveraging the latest current version of Java, in this case, long-term release version. We're using Java 17 today, but we will continually upgrade those Spectra services to take advantage of the Java improvements. Another internal project you may hear about during CloudWorld is something called Graal VM, and this is a high-performance cloud-native JDK. And again, graalvm.org, we're leveraging that a lot to provide kind of that polyglot isolation. It gives both performance and security in terms of when we talk about customization later. This is one of the things where we can run some custom code provided by customers and make sure it's isolated from any other things that if it's poorly written code can't cause issues, performance, security, whatever. And then, a key aspect of performance is scalability on demand, which kind of brings us to the next core principle we've talked about, which is elasticity. If you're familiar with Kubernetes, this is one of the main things that it provides, is this idea that I can, as a developer, I provide the containers, but then Kubernetes has kind of two levels that it can scale at, and we take advantage of both. So, and specifically horizontal scaling. So, cloud native scaling means I'm adding more and more servers, as opposed to I have a single server and I'm making it bigger and bigger. We can either add more VMs, OCI VMs, which is the node scaling, or Kubernetes within those nodes can do horizontal pod auto scaling, independent scaling of each of those services. This is especially valuable for highly variable loads. Batch processing would be a good example of that, where if there's stuff that only happens once a month, payroll, twice a month, payroll, or is seasonal around Christmas shopping, we can be much more efficient in terms of our elasticity and scaling and being able to handle those loads, taking advantage of OCI, taking advantage of Kubernetes, et cetera. Customizations is really important for Fusion apps. Customers don't all run the same version of Fusion apps. They spend a lot of time customizing it for their use. That's not something we want to lose. That's something obviously we think is a big selling point. However, one of the feedbacks we've gotten is that the way customization works today doesn't take advantage of kind of these modern things. They tend to be through a user interface that I go into a web page, I make some changes, and there's no history, no source control, et cetera. So one of the things within Project Spectra we're doing for the next kind of generation of allowing customizations is developing them in a kind of a developer-friendly way, where you would be able to, as a customer, use your own source control or use Oracle source control to deal with collaboration, history, branching, et cetera, and allow kind of CI/CD pipelines automatically then to get built into kind of the test, your test instances of Fusion before running to your production instances. So, treating customizations more like code than that has all those benefits. The T, telemetry. We're down to the T of Spectra. And, obviously the ordering of these is somewhat arbitrary because we tried to make an acronym out of them. But telemetry is really all around detecting issues automatically and hopefully being able to fix them before you as the customer are even impacted. So we want to have all the information necessary to debug any issues that are observed, not have the world where an issue gets reported and then we go back and we try and say, oh, can you turn on the flag? Can you reproduce it? Then we go look at the logs. We want all of that to always be present so we can kind of debug in real time. And again, hopefully before a customer ever sees an issue, and have that kind of end-to-end visibility to allow optimization. So there's basically three main aspects of what we group under telemetry, which are tracing, logging, and then metrics and analytics. And they're all designed to work together. So, you want to be able to take logs from all of this infrastructure, from the Spectra services, from the existing Fusion stack, put them into a common backend, correlate them with metrics. Metrics would be things like IaaS metrics, how much CPU you're using, how much memory you're using, the Kubernetes metrics, how many nodes you're running. And then tracing would be kind of end-to-end from the user interface, being able to trace a message all the way down from, hey, I clicked to change an employee's salary, and trace it all the way from the user interface in the HR system down to the database, and really be able to see kind of where, if there were any performance bottlenecks there, et cetera. But correlate all three of those systems together is a key aspect of telemetry in the Spectra world. Resiliency, again, this is kind of a cloud native core tenet. We provision customer pods completely independent from the other pods. The services are designed to be independent, and we attempt to detect and recover from things like software issues automatically via that horizontal scaling. So if there's a piece of software that maybe has a slow memory leak, runs out of memory, Kubernetes, the system, is going to automatically kind of provision more and replace those ones that have failed because of low memory. And similarly, we take advantage of OCI's availability domain zones that would solve if there was a hardware failure. If you had a server that failed, Kubernetes nodes are going to be spread apart. We'll automatically restart a node if it fails. If a whole availability domain, which could be a rack or it could be a full data center, fails, similarly, the OCI has built in that infrastructure to kind of deal with that failure. And then finally, one aspect of resiliency is zero downtime rolling updates. So if issues are discovered, we can roll an update without necessarily needing any customer downtime to fix a security issue or other things. Fundamentally, all of this, security, resiliency, those are all benefits that kind of lead to better software that you're using. The other thing that's key to us internal is agility. By pulling out these services into independent services, what we're looking to do is bring faster innovation of new capabilities and features to you, the customer, be those things that we've decided are important, or feature requests that you may have filed with us. Similarly, these open kind of interfaces between the existing stack and Spectra services, that same model is being used for integration with other Oracle SaaS, Oracle PaaS services, and easier third-party integrations over time to integrate with Fusion apps. So again, we're building this as a platform to integrate all of the Oracle services, be they SaaS or PaaS or database or third-party, together, and just build a more powerful system over time. So the best part of all of this isn't something I'm talking about that is coming in 3 years, 5 years. You may already be using Spectra services. This has been a project that has been ongoing for a while. We already have services launched. You may be using them already. We have a lot more launching in the next year or two. Again, you're going to see the benefits without kind of even realizing that the architecture underneath has changed. So hopefully you're as excited by that as I am. This is a major transition, and we're very excited, both from the customer benefits, from the internal benefits. The developers are excited. This is something that we've held off on revealing until now, but I'm very, very happy that I got the chance to share it with you. And I am hoping you enjoy the rest of CloudWorld, and thank you for your time.